Swayam Prabha. Digital India. Educated India.
My name is Michel Danino. I am a professor at IIT Gandhinagar, and today I'm going to give a few glimpses on water management in India, and basically in ancient to medieval India. And this will be for a course on Indian knowledge systems that the IKS division of the Ministry of Education is developing. You can see on this title slide a few structures which we will investigate. But before we start looking at those structures, we should understand certain fundamental principles which have guided the evolution of water management techniques, water structures in India. It's very important to understand the context before we go into the details, and why water management was so critical to India for, of course, water consumption, but also very largely for agriculture. The first point is that India has a very diverse geography. We all know this. There's no need to give too many details, but when you stay in a mountainous environment, or in the plains, or in a desert, or in the coastal region, very clearly the water management is going to be very different. That is one. Secondly, climates also, local climates vary a lot. And therefore, all these factors give rise to different types of techniques and different approaches to water management. This needs to be understood. Secondly, even though there are variations in the climate, the general climate of India, let us say, is monsoon driven. And which means that usually there is rainfall only during limited times of the year, not at any particular time of the year as there might be in temperate climates elsewhere in the world. So this means that while there is rainfall, and this is still a problem with us today, while there is intense rainfall, you should capture as much of the water as possible so that you can use it when the rainfall becomes scanty, or sometimes during drought times. This means in particular, therefore, that water conservation techniques and water distribution techniques have to be well studied and well implemented. Then again, the fact that many water structures remain poorly studied. We have a number of studies, but not enough. India is so rich in water structures from, as we will see very soon, possibly 4,000 or 5,000 years ago. And yet there's not enough documentation, and apart from the documentation, not enough understanding sometimes of how they really worked. And this is a field that requires more attention, especially because it's gaining increasing relevance in the context of the water crisis that is looming now all over the world. With climate change, these techniques, these structures will become more and more relevant. Of course, we should keep in mind that unlike some of the modern structures that we create today, for example, colossal dams, unlike these new technologies, the ancient technologies were always appropriate technology. What does appropriate technology mean? It means that they were perfectly adapted to the local context, climatic, environmental, geographical, and also perfectly sustainable. There was, apart from maintenance, sometimes occasionally rebuilding, there was no clash with the local environment, local geology, and so on. So this appropriate technology, this is the conventional term, is something that we need to keep in mind, because now the world is moving back towards appropriate technology as much as possible, since the modern technologies are not always sustainable. Finally, we should keep in mind that the water structures, when we study them, we should not study them purely from a technological angle. India's traditional water structures have most of the time integrated other aspects of life, such as art, religion and spirituality, philosophical concepts also, social customs and practices, etc. As we proceed, we will be visiting a few of them very briefly. Since I mentioned philosophical aspects, let us have a look at a single quotation from an ancient scripture, the Chandogya Upanishad, which conveys that approach to water. And water was something which was regarded as sacred in ancient India. For a variety of reasons we will not go into, but this is still something very alive in Indian traditions. Chandogya Upanishad says, "It is the waters which pervade everything, big or small, the earth, the atmosphere, the heaven, the mountains, gods, men, animals, birds, grass, plants, dogs, worms, insects, ants. All these are water indeed." What exactly is meant is something I will not go deeply into, but I wanted to give this notion of sacredness of water, which we find also expressed in a lot of art forms. For example, these magnificent statues, almost life-size statues, which can be seen in the National Museum in New Delhi, where we have Ganga and Yamuna personified as goddesses, and we can see them holding this pot which symbolizes the river, that is water, and standing on vahanas, the mythical animals on which often the gods and goddesses stand, their mounts, their vehicles, but here they are reptiles. One is a tortoise and another is the alligator, the gharial more precisely. So reptiles are water animals, and therefore we have a whole set of symbolism here showing again the sacred status of these waters, these rivers. Now we are jumping back in time, and we are going to the Indus civilization, also known as Harappan civilization, sometimes called also Indus-Sarasvati civilization, Sindhu-Sarasvati civilization, and so on. It has different names according to who studies it. And here we're going to find a number of very rich, very sophisticated water structures. I will move over them fairly quickly. This is the basic brick well that is found in many Harappan cities, and it has a peculiarity, actually a very discrete but very important technological advance, which is the trapezoid brick. These wells were not constructed with rectangular bricks, which might have slipped inside the well and fallen inside, weakening the whole structure due to the pressure of the infiltrations of underground waters. So to avoid this, the trapezoid shape of brick means that the whole structure can lock together. It's a little bit like an arch, except that it's horizontal, not vertical. And this is quite an advance, because even later civilizations will not have this thought, this invention, you might call it, and will have regular rectangular bricks or stones which will keep collapsing inward, and wells will have to be rebuilt. These wells in Mohenjo-daro had at least 700 of them. These wells were in function for centuries together. They were maintained, which means that silt would have to be taken out from time to time, but they never collapsed inward. So this is something quite remarkable. There are a large number of water structures. One of the best known is this great bath of Mohenjo-daro, which we see here in a 3D model. And what the model shows is that you can see on the right side of the whole structure that there is one room which has a circular feature, that circular feature, is a well. So from this well, the central basin, which measured about 12 meters by 7, with a depth of 2.4 meters, that was filled up with water drawn from the well. And there was a drain at the bottom of the basin, which you cannot see here, but you can see at the top of the structure, you can see that there is a kind of S-shaped drain emerging from it, and this is where the waters could be drained out of when the basin had to be emptied so that the water could be renewed. This has been called sometimes a public bath, but there is basically no consensus on what exactly it could have been. It could have been a royal pleasure bath just for the royal family, or it could have been a bath for certain higher classes of the society, or it could have been for ritual purposes, which is generally a hypothesis that archaeologists embrace, and so on. Whatever it was fairly well thought out, rigorously planned, with meticulous waterproofing due to the bricks that went into it being built on edge, not horizontally as the normal practice would be, and with such a small gap between them that it was hardly 1 millimeter between them. And then there would be a layer of a natural tar called bitumen, and over this a layer of gypsum plaster, something more or less akin to plaster of Paris, and this will ensure the waterproofing. So a lot of thought and planning went into such structures. We now shift to Dholavira, which is a very important site in the Rann of Kutch in Gujarat, and it has the same dates as all the cities of the Harappan civilization, about 2600 to 2000 or 1900 BCE. And I will not go into the details of the city, which is not my purpose here. They are shown in artificial colors here in this graph. But I will go straight to the fact that the city was bracketed by 2 streams of water. But these 2 streams were not perennial, they were seasonal. So during rainfall, and Rann of Kutch today is in a very arid area, perhaps the climate was a little wetter during Harappan times, very likely as per present research. But the point is that to capture these waters during the rainfall, there had to be some structures. And here we see the remain of a stone dam across one of these nallas, which would then divert the waters into the city. And this is a conjectural reconstruction of how a wooden palisade would have held those stones, which could have been then plastered with clay, so that there was a real small dam stopping or slowing down the waters flowing during heavy rain in these nallas. And the result was, after diversion, and you can see on each side of the city, you can see the image of those screens. This is a computer reconstruction showing, again hypothetically, how the waters could have been distributed in the city. However, what is certain is that there are a lot of water structures still visible if you visit Dholavira, such as in the central part of the city called the castle, heavily fortified part, where probably the ruling elite was living. We can see these tanks, which are actually interconnected by underground channels, and there is a complex system of channeling harvested water to them, and there must have been systems to empty them, which were not preserved. However, this is one view of one of the largest underground stormwater drains. You can see the lady at the end of it giving you the scale of it and the massiveness of the stone construction, extremely solid, totally undisturbed even after 3,500 years. And you can see on the left Dr. Bisht, who excavated the site for many years, on behalf of Archaeological Survey of India, Dr. R.S. Bisht surveying one of these drains in the castle area of the city. So there was also a very large tank called the East Reservoir on the eastern side of the castle. You can see the dimensions there, colossal, with 3 stairways leading down into it, and at the bottom of it a kind of step well, very rudimentary step well, leading further down, perhaps for the times when there would be such a drought that the reservoir itself would become empty. Then there would be further water still available through that step well, which you can see on the top right. More structures in Dholavira, such as this very impressive rock-cut reservoir on the southern side of the castle. And the point is that the planning was such that these reservoirs were interconnected through such underground channels. And this means that if one reservoir for any reason received excess water, it could be passed on to the others. So this requires a very advanced level of planning. It also requires, incidentally, a command over a large manpower. And therefore the rulers had to have enough wealth at their disposal to pay those workers for years together, and probably hundreds of them. And this therefore leads to a lot more reflections on the economic strength of the Indus civilization, which I will not go into now. This is the well-known dockyard at Lothal, and for a long time this huge basin of 217 meters, which is almost as long as the entire site itself, because Lothal was not a big city, it was a small town, regional town. The purpose of this dockyard was disputed for a long time, but there's increasing evidence, including research recently done at our Archaeological Sciences Centre at IIT Gandhinagar, to show that yes, it was connected to the Sabarmati river system, and boats, river boats, probably not seafaring boats, could come through the Sabarmati into this basin at Lothal, load or unload goods, and a storehouse was found nearby, and take them all the way, perhaps, to Dholavira in the Rann of Kutch through the Nal corridor. This is something that we will again leave aside. To close this part, there is also a set of water structures, some of them contemporary with the Harappan civilization, but continuing long after it also, especially in Balochistan, called the Kabarbans. And this is actually a Zoroastrian term. And in Sindh also, in Kirnar and all these regions now mostly in Pakistan, this consists of tapping water from a mountain stream by creating artificial terraces on both sides of the stream wherever possible. And this means that the water from the stream, some of it will automatically flow down gently into these terraces, and they can be used for agriculture because they will be constantly not only irrigated but fertilized, since these streams are carrying sediments collected from the hills and mountains. And therefore there's not much work to do for a farmer except to maintain the proper level of these terraces known as Gavarbans. So it's a very simple, again, it's a perfect example of appropriate technology. It doesn't require huge investments. It's very economical and very effective. And therefore we have to constantly wonder why such techniques were abandoned in the course of time to favor much costlier techniques nowadays, which are not so easily sustainable. We now move to the historical period. And before we look at some of the structures, we have to note that there's a major difference with the proto-historical period or Harappan period, which is now that we have texts, we have literature, we have inscriptions, we have a wealth of material that is going to give us data on water structures. For example, let us start with the famous text, the Arthashastra, written by Kautilya. which is probably written in the 4th century BCE, whatever the date may be. The point is that this text lists a number of devices, water structures, but also water divining, water lifting devices, irrigation techniques, taxes that people have to pay for the use of these irrigation works, and so on and so forth. So it's a very important text which gives us not only data on the polity, the type of rule that was practiced, but also the duties of the state towards the farmers, for example. Now, the farmers had to pay for water, but it depended on whether they or their communities had created these water structures, or in which case they didn't have to pay too much tax. But if the water structures had been provided by the state, then there would be higher taxes to be paid. So the whole state structure was very aware of the different situations and was not trying to have a uniform tax structure across the board. They were built by pooling resources from the local communities when it was not from the state, and there could be tax exemptions also of varying durations when new tanks were created or when a tank was renovated. So all these situations are discussed at length in Arthashastra. Now, Arthashastra has a lot about the fines also. The fact that people had to respect rules and laws, and when they did not, then the state came in strongly, according to Kautilya at least, and imposed fines for any digression and transgression. And for example, if someone was obstructing or diverting a water course, and these are things that happen in our times today, they would be fined. If they refused to collaborate in the building of an irrigation tank, or if they damaged embankments, or if they caused the lower tank to dry up by constructing a tank on a higher level. And this is something important. We will find an echo of this later, where when you create a tank, you have to be aware of the entire catchment area for the existing water structures, and the new tank should not disturb what is already there. So all this was very clearly and meticulously thought out, and this is to the credit of our ancient planners. Kautilya deals, as I said, with many situations. I will not read these quotations in full. You can do so on your own. But I want to stop with the testimony of a Greek geographer of the 1st century BCE. His name is Strabo, and he has discussed several parts of India's features as they were known to the Greeks at that time. And he noted that among the officials, the first are those who keep the rivers improved and the land remeasured, as in Egypt, inspect the closed canals from which the water is distributed into the conduits, in order that all may have an equal use of it. So this is an independent testimony from outside India on the importance of these water structure and the intervention of the state, which is the first time possibly, though in the Harappan civilization also there would have been a state managing some of them. Now we move to inscriptions briefly, and there are many of them, actually thousands of inscriptions, which record construction of tanks and wells and ponds and so on and so forth. Not just the construction, but also their maintenance. So maintenance means that you have to desilt any water structure regularly. You may have to repair it. You may have to add certain devices like sluice gates, for example, to control the flow. You may have to create irrigation channels out of a main water harvesting device, and so on and so forth. So all these have names, in the technical names in those inscriptions, usually in Sanskrit, and this is something that has created a wealth of information on all these structures. Water diviners, already mentioned by Kautilya a few slides ago, if you remember, had to pay taxes, which means that it was a recognized profession. It's a long tradition in India, water divining, also known in English as dowsing, and therefore they were acknowledged for their contribution to the society. This is something noteworthy. We have also the echo of what Kautilya was saying about an upper tank not interfering with the lower tank, and this is a 13th century inscription near Coimbatore at Perur, where a Kongo Chola king notes that a new dam, must not affect an older one. The older one should be allowed to fill up first. So the new dam is designed to store water in times of excess. So you see how much far-sightedness is involved in all these water structure, how the ruler has to plan for times when there will be water scarcity. So this is what, of course, every good government should be trying to do. Here now we have an inscription from Andhra Pradesh, 16th century, which I will not read out in full. I will simply say that now there is a religious angle coming into it. You can discover it yourself, by which, and there are many such inscriptions, those who create water structures, who maintain them, are going to earn punya. They are going to have merit, religious, spiritual merit, good karma if you prefer, out of this. So this is an incentive for people to participate in maintaining or creating all these water structures. Now let us look at a few of them from historical times. Again, this is at Sringverpur in Allahabad district, now renamed as Prayagraj, of the 1st century BC, excavated by the late archaeologist Professor Bibilal many decades ago, where he discovered at this site, which is nowadays a small settlement, he discovered a series of massive tanks, which you can see here on the graph, and which were channeling water from Ganga in one direction or another. This is still being studied technically, so I will not go into the actual functioning of the chain of tanks, but I will simply point out to the fact that some of these tanks had again wells at the bottom, as we saw in Dholavira. And apart from that, some of the tanks were actually silting chambers. What is a silting chamber? It's an intermediary tank which is designed to slow the flow of the water. So the water will be slowing down. When water, which carries always some sediments, some clay, some impurities, slows down, then these sediments tend to drop down. So with this very natural phenomenon, you don't need to have elaborate filters. If you have several of such tanks, the water you will get at the end will be much cleaner than the water that entered. So this is something that was quite remarkable in this settlement of Sringverpur. Now we move to South India, where in Tamil Nadu we have this famous structure known in English as the Grand Anicut, Kalanai in Tamil, and where this is a huge structure, but it was not as you see it now. On this photograph you see today's structure, which was heavily renovated by several rulers and ultimately by the British themselves, who did not actually understand the very sophisticated planning behind this structure, who thought that this was meant to be a dam. But the Grand Anicut is actually not a dam. It's a water diversion structure which is meant to separate the Kaveri River into two streams. You can study the details for yourself later, so that not all the water will go into the upper stream, which has more slope, but some of it will go also equally in the lower stream, and this will be used to irrigate a huge area. We are actually in what is known as the wheat basket of the Tanjavur region, and Trichy, Tanjavur, all this region, and therefore the water diversions, which was enormous, it is 320 meters long, was used to control the flow of the water across all these branches of this Kaveri. So this is something still not fully understood. There are actually scientific, technical aspects to it. There's been a study by researchers from IIT Delhi, which I quote here, which found that even the slightly wavy shape of the entire structure had a purpose in the slowing down of the waters. So this is the kind of scientific study which are still not sufficiently developed for our ancient water structures, and which could perhaps, why not, give ideas to modern planners, because the techniques were very, again, appropriate to the local environment, the local geographical, geological configurations, features, which those ancient engineers were giving a lot of thought to. Now we move to Burhampur in Madhya Pradesh during the Mughal era, where we see, and again I will not go into full details, but we see how here we have an integrated water harvesting system right from the slope of the hill, and it's extremely convenient to have a hill when you want to do good water harvesting, because hills are the best water harvesters that you can think of in a natural way. So these hills are capturing water which is channeled through underground tunnels, small tunnels dug into the side of the hill, and again you will have some siltation chambers, and the water will re-emerge in the city, in the town, in some pond which will look like a natural lake. It is not at all natural. This is complete engineering, and it will be a supplement to the city as compared to the Tapti river, which you can see on the left. And this is something which ensures purity of water, which this Tapti river might not always ensure. For example, during the medieval era, there were sometimes occasions where river water was supposed to have been poisoned, and therefore people did not always trust it for drinking purposes. You will note also that there are air shafts, because without them there could be air locks forming in the course of the water, and the water flow downhill, and these will ensure that the pressure of the air gets uniform across the entire path of the waters. Such small tunnels dug in the side of hills had been practiced in several parts of India. In Rajasthan, in Madhya Pradesh, all the way down to Kerala, we have such examples. And here we have now from another region such examples of these air vents, which are again there to regularize the air pressure. But when this system collapses, because there's no proper maintenance, the sediments, the siltation is no longer removed, or some of the masonry might have collapsed, in that case suddenly these air vents become actually wells. They are totally artificial, but they can still collect some water that is flowing in whatever remains of the tunnel. This is what we see in this photo. So these wells, which are said horizontal wells, if you like, those tunnels, which are said to be of Persian origin, though this is debated. In Persian they are called kanat, and they are available in many parts of India. In Kerala, the Malayalam word for them is surangam, and they are sometimes very deep into the hillside, as far as 300 meters, and they are maintained by precise specific communities. And this is something extremely important in India, that most of these activities of creating the water structures, of maintaining the water structures, of using the water structures are basically community distributed, and this is what ensures a good order, a proper working order of those water structures. Otherwise, sometimes it is beyond the possibility of a state to control all this in detail. I will come back to this very briefly later on. Simple water structures like this Khadin in Rajasthan, where you can simply see that there is a bund across a mild slope which will create a small artificial pond, but the water is not taken from the pond. The water is allowed to seep underground and feed a well which is located just downstream from the pond. So it's a very simple but very effective system. Now in forts, and India had many very elaborate forts. We see them all over the place in Rajasthan, typically Gujarat, in Maharashtra and many other parts of India. They were essential devices for the defense of territories, but one fort could be besieged and could have stocked some food, but how do you stock water? Because food is easier to stock, much easier to stock than water. So very elaborate water structures were designed across the forts, which would completely be adapted to the topography of the particular hill or the particular landscape where the fort was located. We go back now to another similar, in fact this is the Mehranga fort in Jodhpur, where we see again that there are several systems at work. There's direct harvesting from the hillside, the runoff water. Then there is seepage harvesting. Whatever goes underground is collected through wells, and ultimately any excess water can go into the city itself. And Jodhpur, for example, is well known for its integrated system, where you have a lot of collection ponds, even lakes, artificial lakes, canals, bunds, and so on. And in fact, you might think that these lakes are natural, but they are not. Everything here is human-made, and it goes to the credit of the visionary rulers that they were able to create all these water structures for the benefit of the population. This is one famous stepwell. Stepwells are beautiful pieces of architecture, mostly in Rajasthan and Gujarat, but in many other parts of North India too. And they are intended basically to harvest, not only to harvest water, and if there is excess water, to fill the underground water table, but they also become places of social interaction. People will go there, especially in the evenings when the temperature is cooler. They may enjoy the water, they may also collect water, they will sit there, they will chat, they will interact. So therefore these are important places from a social point of view. And finally, another completely different type of water structure is found in the alluvial plains, for example in Bengal, where here we have a main canal hemmed in by two large embankments. So that's the main river. But through the embankment, whether the embankment is natural or artificial, you may cut an opening which will divert some of the water towards irrigated fields. And this is a very simple system, but it requires some maintenance to make sure that your opening does not become too wide or does not become obstructed by sediments and so on. So in other words, each region has developed its own devices, and again, all these are beautiful examples of appropriate technology. Now, while we look at more water structures, we're going to look at some very important different aspects, which are the cultural context. We see a fusion, as I hinted at the very beginning, of technological aspects. Of course, any water structure requires some technology, whether it is simple or whether it's very sophisticated. But then there are other concerns entering, which to our utilitarian 21st century may seem sometimes a little alien almost. We no longer have such concerns. This, for example, is part of a remarkable series of structures called Sahasra Linga Talav near Patan in Gujarat. And here we see there is a big bund at the top of the leftmost slide, and behind this bund is a small seasonal river called the Saraswati River. It's not the Vedic Saraswati, it's a later Saraswati. There are many Saraswati rivers in India, and you can see that there is an opening taking water into this beautiful circular basin. Now what's happening here is that, of course, people could sit on the steps if the tank was not full, but as the tank filled up, what would happen is that the outlet which you see at the foreground of this slide on the right side, you have an outlet channel. The outlet is always a little higher than the inlet. Why is it so? If it was lower or at the same level, the water would rush. If it is higher, the water will slow down. The speed will be broken. And once again, by slowing down, it drops its sediments. So the water which is going to flow out, the excess water, is going to be cleaner. And this is something that can be repeated if need be. And then there are multiplicity of channels in this Sahasralinga Talav, and Linga also tells us that there is a religious context. In fact, in the lower slide here, on the rectangular platform which you see, there used to be a beautiful temple which to Shiva, Lord Shiva, which would be surrounded by water, and there would be a stone passage, stone path, only a small part of which can still be seen, leading to the temple, and all of it would be surrounded with water. It must have been extremely beautiful in those days. And at the end of one such channel, we have three small shrines, relics of three small shrines, which were dedicated to Ganga, Yamuna, and Saraswati. Now, neither Ganga nor Yamuna nor the Vedic Saraswati were flowing anywhere nearby. We are in heartland Gujarat. So therefore, this is a reminder. Of course, there is this local Saraswati, which is also a reminder that these rivers are highly sacred, water is sacred, and these rivers are also goddesses, and therefore this veneration for them should be preserved. So here we see an infusion of the philosophical, spiritual, religious aspect into the practical aspect of creating elaborate channels. Just behind this Sahasralinga Talav, you have this famous Rani Ki Vav, which is a UNESCO recognized part of the World Heritage Monument, and where you have this amazing succession of huge steps leading down to the well, and you can see the cylinder of the well at the top center of this slide, which goes down very deep. We will show you a view of it. It's extremely elaborate, and what is remarkable is that all the sides of those steps and the side of the cylinder of the well are lined with hundreds, possibly up to 1,000 originally, of masterpieces of artistic sculptures, mostly of Hindu deities. In particular, one dominant theme here is the Dashavatar, the 10 avatars of Vishnu, but not only. Shiva is also there, Durga is also there, and so on. And the question is, first of all, practical, technological. How do you ensure in such a deep well, which is possibly 20 meters deep, that's very high, how do you ensure that you have these structures well in place, and how do you bring them down Well, this was a very sophisticated technique of creating segments of circles on the ground above, sculpting them and lowering them into the cylinder and adjusting them perfectly so that the dividing lines can hardly be seen. But the second question is, what is the purpose of this? Why are you making your life so difficult by creating those masterpieces of art? And the answer is that everything basically had to be a thing of beauty. This is the philosophy in those days. And therefore, you see all these magnificent panels. This is as you go down towards the cylinder of the well. And not only gods and goddesses like Varaha here, but those beautiful apsaras. The apsaras, which are semi-goddesses, if you wish, are also known as water nymphs. They are actually associated with water, which is why they are present. So all these are masterpieces. As I said, you can study such a panel for a full hour in every single feature of it. And basically it's all meant to create this sense again of reverence, veneration for the water environment that the well provides. There are many more wells in and around Gujarat and Rajasthan and other parts of India, and I will not spend much time in describing them. This is in Dada Harir Vav in Ahmedabad, created in the name of a Muslim lady. So it's not that these wells are Hindu with quotation marks. Some of them, the same spirit was adopted by Muslim rulers, and though of course there would not be statues in the structures, the architecture often would remain similar, and sometimes even some of the floral decoration. So a lot of accessory structures can be seen in those step wells, which deserve a special study, but I will not spend time on them. Now we move to the temple tanks, also called pushkarinis. And to stay with Gujarat, this is from Modhera, the famous Sun Temple Surya Mandir of Modhera. And here we have a magnificent temple tank with hundreds and hundreds of stairs in all directions leading down to it. So these tanks serve at least 2 or 3 purposes. First of all, to harvest water. Secondly, to store water for necessary water rituals, since in Hindu worship, purification through water is very important. And thirdly, to give again this sense of sacredness of water, to impart this sense to the whole population, something that we have definitely lost. You can see here one of the deepest, possibly the deepest step well in all of India. It's in Chanbaudi in Rajasthan, 9th century, which means 1200 years old and still fairly intact, 3,500 steps in across 13 levels. It's a massive construction. It's a feat of engineering and architecture, and it would have served again multiplicity of purposes. Let us move on now. This is an aerial view of the same step well of Chanbauri. Let us move on with more such structures now in South India. This is from the famous site of Vijayanagar Empire, Hampi today, where there are quite a few such pushkarinis, which are basically similar in structure to what we saw at Modhera. And this is testified to by visitors to the Vijayanagar Empire. This is Nunes, a Portuguese visitor, who records how the land was developed, irrigated for years together by a multiplicity of channels and all kinds of improvements. I will let you read this quotation is very instructive because this Portuguese traveler is very impressed by the care with which these water structures have been planned and executed. More such views of other Pushkarinis still in the Vijayanagara Empire. This one is Shravanbelgola in Karnataka, more to the south of Karnataka, famous Jain site, but also there is a Hindu temple with this huge tank, which obviously is not merely for religious worship. It is primarily a water harvesting structure. Some of the river basins were developed, like this one in Tamil Nadu, with hundreds of ponds of various sizes as represented in this graph, where the square shape is not the shape of the pond, but it represents the area of the pond. And you can see that one feature here is interconnection. The ponds are interconnected. This is most important because you can have isolated ponds in a whole basin of a river, but the fact that they're interconnected makes the whole system far more sustainable, because if again a pond receives, or an area of the water basin receives excess rain, which will always happen, rain is not uniform, then the excess water will be passed on to other areas. So these were highly developed, especially in Karnataka, Andhra, ancient Andhra, and including Telangana today, and Tamil Nadu. This whole region has many such systems which fell into disuse during the colonial era. And the reason why they fell into disuse is because the British colonial powers took control of all these civil engineering features, these civil engineering structures, thinking that by creating public works departments in every region of India, these structures could be maintained. It was not possible. It is only because there were earlier dedicated communities, as I said, in charge of the maintenance of these structures for centuries together, that they were sustained. As soon as the government took over from these communities, the whole system collapsed. And some parts of northern Karnataka, for example, were subject to victims of desertification. So this shows how it's not enough to have the structure in place, they should be also carefully thought out. These details you can study later on, when you can see the technical aspects of this whole system. And this, at the end, the last paragraph, is precisely the case of the collapse of the whole region, the Bahmani kingdom. The environment collapsed once the system collapsed. So this was because the rulers at that time were more interested in warfare and not sufficiently in maintaining those structures. But the same thing happened again during the British Raj. Dams also, this is one important dam of Anandpur near Delhi, very close to where I am sitting today, where the dam of 103 meters long, 12 meters high, is still functional, still solid, and its working was actually far more complex than we might think. It was not a simple dam, it was actually functioning in both directions, depending on the time of the year, and these technical aspects were studied by a team in IIT Delhi. Then, of course, lakes and ponds. This is the Munsar Lake in Virangam in Gujarat, built by a queen known as Minal Devi. And this is important because very often inscriptions show that the queens who were not so often in power in India, there were of course a few ruling queens, but most of them were the consorts of the kings, and those queens were actually very concerned with the welfare of the citizens, of the subjects, and they contributed, this is testified to by a number of inscriptions, they contributed a lot of water structures, donated endowments to maintain them, and so on across India. There are hundreds of inscriptions testifying to this. More water structures include these beautiful aqueducts. This one is in Hampi, which are designed to take water from a harvesting area to a place where it's not convenient or not possible to harvest rainwater. So some of them were very long, hundreds of meters altogether at Hampi, as you can see here. And this would require again a lot of manpower, all of it sculpted in granite and very durable therefore. But again, the levels would have to be very carefully adjusted. Finally, we'll have a very brief look at water lifting mechanisms, because water harvesting and storage is the first step. But to distribute water, you need to pull it out very often. So there are primitive systems like here in Dholavira, where water would be drawn, as can be guessed from this slab of stone which you can see, would have been drawn by probably a pair of bullocks pulling a sack of leather, and this would be sufficient to extract water. But there are far more elaborate systems known as this Persian wheel, which, whether again it is Persian or not is debatable, but this is a system, as you can see from the images here, which has a huge rotating wheel. It can be rotated simply through a transmission from vertical to horizontal. It can be rotated by a pair of bullocks. Now this wheel will rotate vertically, and it has buckets tied to it, which will fill up in the water below and bring the water to the surface. So this is simple, effective, and if you visit forts in India and you are attentive, you will see in several of them relics of them. This is at Jodhpur, Mehranga fort, but they are no longer functional. The wheel is still visible, but no longer the whole system. Finally, since I started with appropriate technologies, let us remember that appropriate technologies do not have to be large scale. They do not have to be huge. They can be very small, very simple, modest, as long as they fulfill the needs of the local population. This is the case in northeast India and other parts of some hills, even in the Western Ghats, where local tribal communities practicing agriculture are quite satisfied creating those long networks of bamboo pipes where bamboos are slit in the center horizontally, and this becomes actually channels. The only thing which has to be done is to very carefully adjust their supports so that a constant slope is maintained, and sometimes water from springs in the hills is taken kilometers away to distant fields where the tribal communities are practicing agriculture. So this is a very simple, effective device, and if these communities are satisfied with it, why should they need more elaborate structures? So finally, I refer to water divining. It's an ancient tradition, but it's still alive in India. There are a large number of techniques. I will not go into the minute description of it. This is something that science, modern science, does not understand, is not able to explain, but it works absolutely without any doubt. All those who have witnessed it, I have myself, will tell you how effective it can be. And if you do not use a water diviner, you may often fail in finding proper water. So whether you use a coconut, as you can see on the left, which will lift on its own when water is crossed, or whether you use a pendulum, there are many techniques. But the point is that it is something that is ancient. It is described, as I mentioned, in Kautilya, Arthashastra, but also in Brihad Samhita of Varamihira, and discussed in many inscriptions. I will let you study these details. We have now to conclude with a number of great figures whom again I will let you discover. You will read these texts and you will discover, if you do not know them, these well-known figures who have actually revived those ancient traditions in different regions. Sundarlal Bahuguna did this in the Garhwal region of the Himalayas, Rajendra Singh mostly in Rajasthan, and basically they have gone back to this whole philosophy of appropriate technology, what is friendly to the environment and what fulfills the needs of the local people. And they've done outstanding work. They are not the only ones, there are many more. Anna Hazare is well known mostly for other regions, but he began with these very important eco restoration perspective and practices. Anupam Mishra is another, and they are all champions of those water harvesting structures. There's a wonderful short TED video, TED talk by Anupam Mishra, which I would enjoin you to see, and I will be sharing the link in notes accompanying this talk. So this is something that I've already explained, how the Public Works Department, instituted during the colonial time, ended up ruining many of these structures because they did not understand how the local communities were effectively, efficiently maintaining them. So lessons from the past, it's always very important when we study these past traditions, these Indian knowledge systems, very important to understand what can be still applicable to today's context, what is still relevant, what our modern engineers could still learn from. And first is that large projects can fail. They can fail because of silting, evaporation, loss of water in transport, flash floods. But smaller, decentralized water management systems, as we saw in this talk, and there are many more which we do not have time to cover, are more sustainable. And if the local communities can participate, and they should be encouraged to participate, then the sustainability will be ensured. These lessons from the past are important, and in whatever Indian knowledge system we study, we should always remember to draw these lessons, to study their relevance and what message they can give us today in the context of the 21st century. It is not that we can always adopt them as they were, but we can adapt them to the modern needs and context. So let us not think that these are bygone techniques, bygone practices, not relevant to our modern technological era. We will be doing a mistake if we neglect them. We have still a lot to learn from them and to understand their philosophy, which was ultimately to benefit the population at large. Thank you.